Hello there. In this video, I'd like to talk about counter instruction. Compare with timer instructions, counter instruction is relatively easier. Uh, there are lots of similarities between two of them, but yet counter instruction has something unique. Right, let's have a look. So first on this slide, you see the comparison between the tags, right? You use different data type of tags to represent timer and counter. So this is the structure with timer, right? So on the right-hand side, you can see once you set up the data type as a counter, you also have a structure. So within the structure, you have a very similar members. So for example, the first two, preset and accumulate, it's the same to the timer structure, right? Both of them are data type of double integer. And then after that, with counter, it has two members, CU and CD. Count up, count down, right? I will explain more with these two. So you can consider this CU and CD similar to the enable bit with the timer. All right. Whenever the trigger is true, those two bits CU CD will become true, right? And counter doesn't have the timer, right? Doesn't have the TT bit, right? But the done bit is the same as the timer, right? So whenever the accumulate greater or equals to preset, that done bit will become true, right? Similar to timer. And on the bottom, you will see two members with counter, OV and UN. OV is overflow. UN is underflow. So those two bits, control bits, I can see they lose their significance now because with 32 bits double integer, right? So because the accumulate and the preset, they are double integer 32 bits. So you can see their range, you can see here, range from -2 billion to positive more than 2 billions, right? That's a huge number. So basically overflow, underflow is just whenever you have the accumulate, if it's overflow, that'd be bigger than the positive 2 billion, 147 million, 483, those big numbers, right? So that's overflow, right? But if you count down, if you go below this negative range, like negative 2 billion, 145 million, something like that, right? So those two bits will become true to remind you, okay, your number is going too big to cross the limit, right? But as you can see, with this huge limit, right now they don't really make a lot of sense now, right? So that's why it loses its significance. But before, with the 8-bit or 16 bits controller, they make sense, right? You need to keep track of that, right? So that's about that. So with the instruction, there are two of them. All right, so CTU, CTD. All right, so you can see count up and count down. All right, so they have one shot to build in. So you will see a demo. What I mean by that, right? And count up and count down, and done is when they accumulate greater or equals preset. Also, the counter can be reset by using RES instruction or by clearing the accumulated value. So that means you directly operate on the accumulated value. You can change that to 0. So that will identical to reset the counter, right? So that's basic introduction with the tag and instruction. So now I'd like to introduce a demo similar to before. I will put the link underneath. So we talk about a like a conveyor belt, right? So we have both sensors at each end of the conveyor to sense the part being dropped by the robot and then picked by the operator. So we want to control the motor of the conveyor, right? So one thing special is that you can see the both instruction can operate on the same counter tag. The idea for monitoring parts in the process, you can see here, drop, pick, trigger two sensors. Two sensors trigger two instructions, but you can see that both tag name. Oh, sorry. So both tag names are the same. We use the same counter tag, right? So this is a very good solution. So this unfavorable solution is that if you use two separate counter one, counter two, to do the count separately, then you have to use the math instruction to subtract to calculate them, right? Definitely, this is not very good compared with this side, right? So this is one thing. It's really a little bit special with counter, because normally, if you think about timer, normally you don't use the same timer tag for the on delay and also off delay. That's gonna mess up your logic very, very quickly. So that's almost nobody do that. But with counter, right? So you can use CTU and the CTD to operate on the same tagger counter tag, right? So that's something unique for the for the counter instruction. All right, so let's look at the demo I put over here. So let me open up here. So first, let's look at here. So the drop is on this side on the robot, right? So first, I compare that with the double integer solution, right? So you can see whenever the drop sensor on this side is being triggered, the counter will count up, right? So we set up the preset at 5, and that right now is 0, right? The parts somehow become 10. All right, I can clear that to 0, right? That must be because I did some test before the demo, right? So right now I clear up the double integer at 0, right? So let's see over here with the ADD, we have to have one shot, right? And that's a separate instruction, separate video. I already talked about that, right? So that's what I just want to do the demo. So when I click the robot, I'll simulate the robot will drop a box on the conveyor, right? So you can see here. So the sensor triggered become close, right? Then that's become true. You can see here, right? It can't accumulate to 1, and same thing on the double integer, right? You can do that with double integer, but you have to use one shot, right? So that's something over here. It's like a counter can have a built-in one shot, right? So that's what first thing I want you to know. Second, you can see here, I also use the peak side, right? No, remember, this is normally close. Again, that's a different video. I don't need to explain that for in here. So we have to use exam off, because that's a normally closed sensor, right? So whenever the part reach to here, that will count down, because operator will pick it up. So that's going to remove the part from there, right? So let me just demo from here, right? So if I drag this on here, so simulate there's a part on in the middle of the conveyor, right? So then if robot drop a second part, right? So you can see here, now we have the trigger to increase the accumulation to the two parts, right? So over here, we record the 2 parts out here, right? So, and let me demo the countdown, all right? So right now there are 2 parts on the conveyor, and then if we drag this, simulate the conveyor, move that to the pick side, and then that sensor change to open, and that will trigger countdown. So now you can see because it's there, right? So it automatically reduce by 1. So right now it says only one part of the conveyor, right? So if we I'll use this to simulate the operator pick the box, right? And then you can see here the last part is still on the conveyor, right? So that's why it's here. And then if I drag that into the pick site, right, that will count down to 0. Accumulate is 0, and operator can pick it up, right? So in this way, you can see over here, you don't have to use a double integer, right? Clearly, the counter is a better solution. Use the same one to track how many parts, right? They accumulate on the same uh, counter tag will indicate how many parts on the conveyor belt, right? So now let's just do a conveyor control, right? So now we'll simulate on a conveyor, we can hold up to 5 parts, right? So that's what we set up the preset. And also over here, we just need to make sure operator ready to the, it's not a mistake by pressing the button. So we need operator press and hold this button for 3 seconds on delay, and then let the done bit, you can see here, the done bit will replace the start button, right? So that's why button need to be hold for 3 seconds to start the run, right? So again, this part is from the previous video, right? So let's start the machine. So operator will press and hold the start button, start accumulate to 3 seconds. Then you can see the run bit is on, right? So over here, in the same way of the stop button, we insert another condition. So this one is from the counter. So the counter's done bit, we use exam off. So right now it's 0, right? It's not done. So if it's not done, that means not reached to 5 yet. So we want the system to run. But imagine if that the accumulate reach to 5, this will become false. Right? That simulate like this is a manual stop button. This like a automatic stop, right? System generated, and that will cut off power to the run. You stop machine, right? So that's part of the control, right? So once the counter is done, motor should be automatic shut down. That's what I mean by this part, all right? So let's look at the, let me zoom out a little bit. So there's some control on the motor. Let's look at here, right? So run bit is true, so it's here. So it's just waiting for the part being dropped. So once that become true, before reach to the peak side, the motor will become true. Right, so I demo this in different video, so let's look at here. So we drop one part. So you can see here, motor is running. Right now, motor is running because here, right? The accumulate, you can see here, accumulate reach to 1 now, right? So motor is running. So now let's move here, right? So that drop sensor lose the continuity, but because we have motor on here, right, that bypass it. So that's what we programmed before in different video. I demonstrate that. That's called seal in. Now we add another condition. You will see why I add this condition over here. Right now, this is GRT greater. So compare with the accumulate with 0. Right, this also become true. Actually, we have 2 branches, both become true in the same time, right? So motor is running, so that's simulate, we drop another part, right? So robot will drop another part, right? So now the accumulate become 2, right? So remember there are 2 parts on the conveyor now, right? So let's just simulate if we have one part, right, being transferred underneath the peak sensor, right? So once that happens, you can see motor automatically stop, right? Because the peak sensor lose the continuity, right? So you can see motor stop, then let's try pick up the part. Once the operator pick up the part, what will happen? This will become true again, right? So that will become true. But you can see here, before reach to 5, motor should restart if the peak side is clear. If that clear, then how can we restart a conveyor? So this is why the third branch is the third branch, right? So because right now we have two parts, one part at the peak side, right? Once we make that disappear, this still become true, right? We lose the seal-in motor because of the peak sensor, but now the third branch keep become true, right? It's just waiting for this clear. So that's make that clear. Operator pick the part. So you can see the motor automatically restart again. That makes sense, right? Because you still have one part on the conveyor, right? You don't have to ask operator to press the start button or do anything again because you have a counter, keep track how many parts on the conveyor. Because if this branch is true, energize the motor. Then motor right now, it's not necessary, but we have to have that in their design, right? So that's just keep going, right? So if we reach to 5, right? We reach to 5, the counter dump bit will become true. This will cut off that. And when we lose the run, right? So the run become false. We could not restart from this top branch anymore. But you can see here, we can add another control called manual purge, can be used to clear parts after automatic shutdown. So that means you can see here, there's a separate branch. We just use one select switch or any type of control. It's like a menu, right? This is like automatic. This is the menu bypass. So as long as the peak sensor is clear, we can energize the motor. So for example, right? So if nobody the operator is not present, it's lazy or not doing the work, right? So the part being piled up on the conveyor, right? So we can have the limit up to 5, right? Once it's 5 reached, system should automatically stop, right? Once stop, you can use manual bypass to purge the part or put the system back into the automatic run. I'm going to demonstrate here, right? So right now you can see parts on the conveyor, there's 1, right? So I'm going to pick a robot drop the second one, all right? So now we have 2 parts on there, and then robot third part on there. There's 3 of them, 4 and 5. So once we reach to 5, you can see here, right? That cut off the run. So that motor de-energizer here, right? So even that right now, if I'm the operator, I'm running back. Okay, I need to press the start. So I can press start, hold for 3 seconds. You can see here, that's become true. But because here, right, it become false. There's no way you can restart it automatically. You can see 3 seconds done, it's true, right? Because counter is there, right? Prevent that start running. From running. So that's now okay. So we can go to the menu purge. So that's the SS. So now we can switch to menu. So you can see here that bypass all the conditions on the auto run and then motor running again, right? So that's simulate that. So the part being transferred under to the peak sensor, right? So that motor automatic stop, right? So now operator can pick the part, right? So once pick the part, you can see because this is a selected switch, right? It's running out here. But yeah, less dump bit is not true anymore, right? Because right now accumulated is 4, right? 1 less, right? So we could switch back to auto, right? But I'm just gonna continue to demonstrate another menu mode, right? So if, for example, we wait for the other part reach to the peak side, right? So now the operator can pick up this second part, right? There's 3 parts left in there. Again, it automatically start because the purge, the switch here, this is maintained, right? So now if I I say, okay, I don't need the manual mode anymore. I can turn it off, right? Automatically, the motor stop right now. So now we can try to switch back into the auto mode, right? So if the operator press and hold the start buttons for 3 seconds, then the run bit come back. When run bit come back, because 3 is still greater than 0, so that will become true, and then turn on the motor. Right, so now we can continue to do the normal operation, right? Automatically go back to the pick, and then that reduced to 2, right? But still running, right? It's just waiting for the operator to pick the part, make that disappear, so then restart again. So this is like a better design with the more tolerance and also different control modes, right? So this is one thing I want to demonstrate. So the conveyor belt with the part present and also parts count. All right, that's something I want to demonstrate first. All right, the other thing I'd like to talk about with the counter is that something really special is that when do you want to reset the counter? Because at some time you always will reset the counter to 0. Not always, most of the time, right? So the one I demonstrate, I didn't include the reset, right? But you can imagine in lots applications situation, you have to reset, right? And in some situation, that's done by the dump bit from the counter, and that can pose a problem. So over here, in order to demo, I use 4 counters to compare them. All right. So the first one is the problematic solution. Right. For example, you can see I use same trigger to trigger all 4 counters. Right. So the first one, we just use the exam on with the dump bit on here to start the RES reset instruction on counter 1. The problem with this solution is that for counter 1, after reset everything, the trigger generates a false count before it turns off. Right, so you can see here that simulation on here. So that simulate after reset, it generate false count on here. But you compare with the solution on these two, you can see here, right now accumulate is 0, but this one is different one. All right, I'll explain that. Right, so let me maybe demonstrate that. Right, so that's just on here. Okay, program it here. All right. Okay, so you can see here I already increased accumulate to 2. I already tried twice, right? You can see CNT 1 to 4 accumulate, they all become 2, right? That's good, right? So that's the same. So I'm gonna Control T to trigger that, to toggle the trigger, right? Control T, then you can see all of them increase to 3. So they are good. That's a normal operation. And turn it off and turn back on first time, right? So this is 4, right? That's if I toggle that, now I can toggle off. If I toggle become true again, they all become done, because the preset is 5, right? And then you will see a very strange situation after you reset, right? Remember, no matter how fast is the trigger, the PLC always run very, very fast, right? So that trigger will give the next scan of PLC a push to increase this accumulate to 1. But that's a false counter, right? Because you can see here, maybe I can show you, right? Control T. So you can see this is number 5, right? This is 5, right? You're supposed to reset that back to 0, but you can see here, CNT 1 already increased by 1. So this number 5 trigger actually not only increase to 5, become done, also being counted into the next one. being counted twice. So that's what I mean, false count, right? Because one true become trigger twice of the counter, right? But you can see the other three counters, they didn't, right? Especially 2 and 4, right? They keep the accumulate back to 0, right? So if I change that trigger back to false, and that simulate that, you can see here all three of them, 2, 3, 4, they all 0, which is right, because I only trigger 5 times. But with CNT1 is already accumulated to 1. So that's a false counter, right? So that's the problem with this kind of design, right? And 2, 3, 4 is the solution. I recommend you could find other solutions. All right, right over here, I just gave you a clue. So for CNT2, we add 1 shot after the trigger, so it only count 1 scan. So remember, I just talked about a counter has the 1 shot built in, right? So we don't have to use 1 shot with counter. But in this CNT2, we use 1 shot down here. It has a special meaning because we only want this become true once. So in this way, you can see the false count will not increase that to the 1, right? It just reset that. You can see here is identical solution with CNT1. The only difference is to insert a 1 shot. So this is a very good solution, right? Not bad at all, right? The other two, CNT 3 and 4, it's just I'm trying to have a different solution to play with the instructions, right? So you can see I can present to you, but it maybe it's not the solution you prefer. Let's see, look at the CNT3. Delay RES until trigger turn off. You can see here, it's done, but we need to wait the trigger become false, right? When it's still true, I don't want to reset it. So it become false, right? That will become true. I reset the counter. So after I reset the counter, because the trigger already false, right? So that won't generate another false count on CNT3. So that's the reason I insert this on here, right? And CNT4, you can see here, I directly use match instruction to clear that ACC accumulated value because it's double integer to 0. So that will do the same thing, right? So again, you may have a different solution. You can try it, all right? But this is just some problem with the CNT1. I'm gonna do the demo again, all right? So right now, CNT1 already accumulate to 1. I need to clear that to 0, right? So let's start from beginning, original state. All 4 counters are 0, right? So then let me do the demo again. So 1, 2, 3, 4, here it comes, all right? 4 become false, and then if I trigger next time, right, CNT1 will have a problem, but the other 3 are good. You can see here, right? The other 3 are good. So you can see here, right? The other 3 are 0 because they are being properly reset. But if you look at CNT1, because we didn't do anything, it just rely on the reset, it generated a false count on here. It's already accumulated to 1. All right, so this is the demo I wanted to do.